Okay, lesson 27. Aaron needs 2 animals for his petting zoo. His farm has 15 ponies and 6 alpacas. He randomly chooses one animal, which is then removed from the pen. He then chooses a second animal from those still in the pen. What is the probability that both animals chosen by Aaron are alpacas? Okay, so we want to know what is the probability of choosing an alpaca given that you chose an alpaca the first time. So I would say you have which is then removed from the pen. Okay, so this one is dependent events. And so I'm going to just talk this out. So picking the first animal versus picking the second animal. Okay, well, in the first selection, he has 6 alpacas that he could choose from out of a total of 15 plus 6, which is 21. So in the first pick, he has 6 options out of the 21 animals. Since that's removed, and he wants to know what the probability is that both animals chosen by Aaron are alpacas. So then in the second selection, if the first one that you chose was an alpaca, that means you only have 5 alpacas left to choose from. And since he removed that animal from the pen, there's no longer 21 animals to choose from, there's only 20. So we are looking for what is 6 times 5, that would be 30, and 21 times 20 is 420. Okay, and then we can reduce this by 30. 30 goes into itself once, and 30 will go into 420. Let's see. 420 divided by 30. 14 times. So we have a 1/14. There we go. Submit that for grading. Let's check it. Great job. So again, I just thought of the probability of each choice. Alright, so Mr. Brady needs 2 students from his class to help him with a science demonstration. His class has 18 boys and 6 girls. He randomly chooses one student who comes to the front of the class. He then chooses a second student from those still seated. Okay, so these are going to be dependent because those still seated, that first student didn't go back in and sit down. They stayed at the front of the class. Okay, what is the probability that both students chosen by Mr. Brady are girls? Okay, so I'm going to think of this on the first selection position and a second selection. So this is my first time picking, and this is the second time picking. Alright, so the first time, if I choose a girl, there are 6 girls out of a total of 18 plus 6 is 24. So there's 6 girls out of a total of 24. Then on the second pick, if you chose a girl the first time, there's 5 girls left out of, and since that student went to the front of the classroom and stood there, there's no longer 24 seated, there's 23. So then we have 6 times 5 is 30, and 24 times 23. We have 24 times 23, that's 552. Since they both end in an even number, well, 0 and 2, I know it's divisible by 2, so 30 divided by 2 is 15. 552 divided by 2, whoops, let me select this. 552 divided by 2, 276. So it reduces down to 15 over 276. Which our work matches right here. 6 out of 24 times 5 out of 23. Apparently 3 can go into 15 and 276, so it would reduce down further to 5 out of 92. So let's check that. Great job. So I selected the answer based off of my work because 15 out of 276 doesn't look like 5 out of 92, but that just means that 15 out of 276 is not reduced all the way. My work is the same though, 6 out of 24 times 5 out of 23. So that would reduce down. And then so I'll just show you for a second. 15 divided by 3 is going to be 5, and 276 divided by 3 is going to be 92. So it is the same answer, I just hadn't fully reduced it. So 5 out of 92, 5 out of 92. Okay, question 7. There are 12 sodas in a cooler in which 6 sodas in total are the store brand and 4 sodas in total are colas. There are 2 sodas that are both the store brand and colas. Let A be sodas that are store brand and B be sodas that are colas. What is the probability that a soda is a cola given that the soda is a store brand? Okay, on this given, that restricts your total number of sodas right from the get-go, because it is saying, okay, you already, out of the selection that are store brands, what's the probability that it's going to be a cola? So in my mind, I'm first automatically visualizing this. So if this is going to be A, sodas that are store brand, and B, sodas that are colas, then I'm gonna draw this in which 6 sodas in total are the store brand. 6 sodas in total. That means everything in here has to be 6, and 4 sodas in total are colas. And there are 2 sodas that are both the store brand and colas. So since there's 2 here, and they said there was a 6 total, I've got to take 2 from 6, which leaves me 4 that are store brand and not colas. And then we're going to do the same thing. Since there's 2 right there, and they gave us that there was 4 in total, we have to make sure that that whole circle totals up to 4. So since there's 2 that were store brand and colas, that means there's 2 that are only colas for a total of 4 in this circle. So this circle needs to total out to be 4, which it does now, and this circle needed to total out to be 6 because it says in total. Okay, so that's how you would first draw your Venn diagram if you are a visual person, which I am. And so now they want to know, what is the probability that a soda is a cola? So probability of a B, given that the soda is store brand. So given that it's A. And when I have a Venn diagram, I honestly am not worried about a formula because I can visualize it. So this is saying if I restrict my option just to A, just to the store brand, okay, what's its probability that it'll be a cola? So, and that's this little section right there. So the how many choices do I have if I am restricted to just A's circle? Well, I have 6 just in A's circle. And then how many ways can I pick that it was a cola? Well, there's 2 ways out of A's circle to pick it, which 2 out of 6 reduces to 1/3. So that's how I would use a Venn diagram. Now, how would you use the formula? Probability of B given A is going to equal the probability of B and, probability of A and B, the intersection, divided by the probability of A. Okay, so that would equal, well, let's do the probability of A first. Well, to be in A's circle, how many are there? And right now, for A's circle, we have this, and there's a total of 6 in A's circle out of how many sodas? There's going to be 10 sodas in total. So the probability of just picking one that is store-bought is 6 out of those 10. And then what is the probability of A and B? Okay, well, we're looking for that intersection, which is right here. The intersection is 2 out of 10. And then I'm thinking back to my algebra skills. Okay, well, I have 2 out of 10 divided by 6 out of 10, and I'm remembering that when we divide fractions, we multiply by the reciprocal. So it's 2 out of 10 multiplied by the reciprocal, and the reciprocal of 6/10 is 10 out of 6. So that's going to equal 2 times 10 is 20, 10 times 6 is 60. So 20 out of 60 is 1/3. So we end up with the same solution, just 2 different ways. So this way is the formula, and the first way was just using the Venn diagram. So the probability of probability that a soda is a cola given that it is store brand. And this is how I remember what order they are going in. Okay, a soda is a cola That was B. And given that the soda is a store brand, so store brand was A. It goes in that exact order. So I'm looking for something that says B given A. So I'm looking for B given A. So this out of these two choices. And then we're looking for the probability of B and A, the intersection, divided by the probability of A. So I'm looking to make sure that the denominator is the probability of A. Yes. And then this is going to be 1/3. Great job. Okay, question 6. Event A is equal to X such that X is a king card, corresponds to drawing a king from a standard deck of 52 playing cards, and event B is equal to the set 6, corresponds to rolling a 6 on a standard 6-sided die. Are events A and B dependent or independent, and why? Okay, so right from the get-go in my head I'm thinking yes, they're independent because it's a deck of cards and a 6-sided dice. There's two different objects and they're not linked together with a condition. So in my head, first off, yes, I know that they are independent, so I'm going to delete the ones that are dependent, and then I'm going to read the reasons. Because the probability of A is equal to the probability of B given A, which equals 1/13th, or is it because the probability of B is equal to the probability of B given A, which equals 1/6? So they're going back to the independent or multiplication rule. So if you scroll up in your notes or in the level up, you should have that the probability of B is going to equal the probability of B given A for independent. And so let's find out what the probability of the next thing I'm looking for is that this one is not set up right based on the formula, because I'm noticing a positioning place. This B was positioned in the first place. So then if I have the probability of A, the A should be in the first position. So just by observation, I'm going to eliminate that one. And let's select this one and just see if it is correct based on observation without doing any calculations. And yes, it was. So now, why was it? So if we found the probability of B, which is rolling a 6 on a standard die, so probability of B is going to be 1 out of the 6, which equals 1/6. It's not reduced at all. So then probability of B given A is going to equal the probability of B and A divided by the probability of A. then we are going to have how many ways can you have draw a king card and a 6 on a dice, and that's only one way. And then how many ways can you roll the 6 standard? How many options are there on a 6-sided dice? And that's going to be 6. So that's 1/6, and they are the same. So in the previous example with 7, they used this n. That's the number of ways. So, and it is interchangeable. So the number of ways you can select a king card and a 6 on a dice, there's only one way you can do that. And then the number of ways for our event. Did I write that right? Yes. I'm just going to edit that out based on observation. Okay, question 5. I want to know why. Okay, events A and B are associated with the following probabilities. Probability of A is equal to 3/4. Probability of B is equal to 1/3. Probability of B and given A is equal to 1/3. Are events A and B dependent or independent, and why? Okay, so we need to set up our formula, and if I have it in my notes, I'm remembering that it is probability of B is equal to the probability of B given A. So, I want to know, well, the probability of B is 1/3. And fortunate enough, we have the probability of B given A, which equals 1/3. So yes, they are independent because the probability of B is equal to probability of B given A. And the order there does matter. Okay. Good job. Okay, question 4. At Central Online High School, 45 out of 100 of the children have a dog, 30 out of 100 of the children have a cat, and 18 out of 100 of the children have both a dog and a cat. What is the probability that the children who have a cat also have a dog? So they want to know, what is the probability of having a dog if you already have a cat? So there's 2 ways we can do this. So we can use the formula probability of having a dog, given that you already have a cat, is going to equal the probability of dog and cat divided by the probability of having a cat. So that would equal, well, the probability of having both a dog and a cat is 18 out of 100. 18 divided by 100 divided by the probability of a cat is 30 out of 100. And I'm remembering again, okay, that means I have 18 divided by 100 divided by 30 over 100. Multiplying fractions, you're going to multiply by the reciprocal. So 18 out of 100 multiplying by the reciprocal, so that would be 100 over 30. And I'm going to leave it as 18 times 100 over 100 times 30, because the 100 over 100 reduces out because it reduces down to 1. So that will leave you with 18 over 30. That's going to equal 6 can go into both of these. 18 divided by 6 is 3, and 30 divided by 6 is 5. So we have a solution of 3/5. Great job. So now if you are a visual person, then we can do it with a Venn diagram. And I'm going to do it again using a Venn diagram. So there's our Venn diagram. We have dogs, we have cats, and we have the intersection of both. Okay, we have 45 here, we have 30 here, and then this 18 that have both. So in order to account for the 18, the dog circle total has to be 45. So I'm going to take 45 and subtract 18 from it. Because I need to keep my total, so 27. So we have 27 and 18. And the reason I did that is because that total has to remain 45. So let's check. Did it remain 45? Well, it's 27 plus 18. It's 45. Okay, so then we have to do the same thing. The cat's total was 30, but 18 of them lie in this intersection. So how many don't have a dog? So what is 30 minus 18? It's going to give us 12. So there's really only 12 kids that only have a cat. And we can double check and make sure that our cat circle still totals up to 18. So we have 12 plus 18. That equals 30. Okay, so now since we have our Venn diagram set up, we want to know what is the probability that children who have a cat also have a dog. So we could also do this. Okay, they gave us our restrictions. The people who have a cat. That means I'm only looking at the circle that represents cats. So I'm looking at this circle right here. And I'm remembering, okay, they want to know what portion of that circle have a dog. So out of this circle, there is 30 total in that circle. 18 and 12 is 30 total. And out of that, 18 of them have a dog. So we ended up with 18 over 30, which we know reduces down to 3/5. So that's another way of doing this same problem, just by visualization with our Venn diagram. There is your help for you. And if you need further assistance, let me know.